Hello YouTube, this is Zubairullah Inom. Welcome to the next episode of AZ Academia YouTube channel. In this class, we are going to discuss the result of our simulation, which we have done in the last 4 to 5 classes. In the last class, we did uh, some modification in the uh, wireless power transfer model, which we did in Simulink. Sorry, in ANSYS Maxwell. In the last class, we draw the second part, the secondary part of our coil, and also we injected the excitation in the primary and in the secondary coil. And also in the last class, we saw we inserted the parametric changes, and also we did some mesh operation modification, and these things we did in the last class. And also up to this part we validated, no part was left unchecked. So, and also we went through analysis. In this class we're going to see the result. In this class and in the upcoming class we will go with the result, and also we will see what was the outcome of our drawing in the last classes. To be honest, the recorder I'm using, it's only 10 minutes limitation. So if there are some part left, so I'm going to continue it in the next class. And also I should mention here that after finishing this class, we will continue our simulation in ANSYS Maxwell for for eddy current solution type. In the last class, we did magnetostatic solution type, and this magnetostatic based of your basic electrical engineering knowledge is used only for DC analysis. But in case for AC analysis, we are going to for AC, and we are going to change the parameters, and we will see what will be the result. In the maybe after doing that, we will have uh, some validation in the simpler or twin builder, which is integrated with this platform. So, in the after running, actually, something we are seeing here in the message manager or in the progress. This is not related to this one. It's actually this is related to electros eddy current analysis, which we will discuss in the coming classes. So after running your simulation, and what you're going to do, just you're going to do create a magnetostatic report, rectangular plot. If you're interested for some uh, graph representation, you're going to go through directly to rectangular plot. Or if you're interested only in the data table, you're going to click the data table. Suppose if I am interested to data table, I'm going to go to result, then right click, then after that we are going to create magnetostatic report and then data table. In this data table, you will see you are going to choose matrix from parameters, and also if you want to uh, your sweep be the dx, the changes in the z direction, you're going to click this dx. If you're interested on the primary sweep based on the current, you're going to click that. So it's fine for that, because now there is uh, no problem with this. So what are you going to do? You are going to choose magnitude from here. But if you're not choosing magnitude, no problem. Just you are interested in the coupling coefficient. We are interested in that coupling coefficient. Obviously, the coupling coefficient will between the same coil in the primary coil will be 1, but in the very interested in the TX and RX. So because the coupling coefficient we are interested is between the primary and secondary. And also in the inductance, we are interested in self-inductance in the primary side, self-inductance in the secondary side, and self-inductance, mutual inductance between primary and secondary side. I have done actually these things previously here, so no need of proceeding here. Just I'm going to show you the result. So I'm going to close this one. Coupling coefficient name. This is the name. You can change it whatever you want. So just I'll double click it and I'll see the result. See, this is the coupling coefficient and this is the rectangular plot result. In the rectangular plots result, you will see this is the changes in the z direction, and also this is the coupling coefficient between the primary and secondary. As you can see, when there is 20 mm air gap distance, which is 2 centimeter, and it's quite interesting. You see that it's almost 1, not 1, maybe 0.95, but as you're getting closer to 120 mm, you're going to see that it's almost at 0. And you see once you're increasing the distance, the coupling coefficient significantly reduces. So again, another thing I can show you here is the self-inductance. So in self-inductance, you see the here the self-inductance. See, I guess this is without the core and this is with core. So, but one thing I should tell you that whenever you want to actually in the last class we did with only without core, and if you want with core, you will have better result of mutual inductance and coupling coefficient. So now if actually I don't have here the data table, I have to go and check my data table. So I'm going to go to data table. Then what I'm going to do is clicking in the L stands for inductance. So I'm interested 2x dx. I have to choose dx here. dx rx self-inductance between in the secondary side, self-inductance between primary, mutual inductance between primary and secondary, and mutual inductance and self-inductance in the primary side. We TX mutual inductance between primary and secondary to primary is same. So out of those two parameters, we only choose one parameter. So next we are going to see neuroport. So see, you can see here. This is the report which we got. When there is 20 mm air gap, we will get 775 microhenry in the mu henry in the primary side, secondary side, self-inductance, and 775 in the primary. And we will get 739 mutual mu henry mutual inductance in the mutual inductance, which is quite interesting. As you're increasing the distance and you see there is changes, you can see changes will be very significant and quite large. So yeah, this is something which we got the result. In the next class, I'm going to show you the field for the magnetic flux, the flux in primary, the secondary, and also these things we'll see in the next class. Thank you so much for watching this video. If you have any questions, you can write it in the comment section. If you have any question or any doubts, you can share with me. I will learn also from you, and if I have some mistake, you can correct me in the comment section. Thank you so much. Have a nice